Welcome back, and thanks for joining us for another episode. We're going to talk today about some common infrastructure concepts that you should know. And you and me, just in general. It's good to know this stuff.
I hope I know it.
Yeah, let's hope.
This is going to be an interesting episode.
We'll just start the sentence and see where we end up.
Let's see here. Infrastructure. What do you mean by that?
So we have a couple different things we're going to talk about today. Let's start with serverless infrastructure.
Serverless. It's serverless technology.
Serverless technology.
Yeah,
okay.
Think about it. Yeah. Well, we fall under the infrastructure rubric, if you will. I get to use that word every day, and that's a fun one. Because it is probably supporting your infrastructure. But the cool thing about serverless is, let's start off with this. Fun fact, serverless technologies still have servers. You're like, how the heck does that work? See it in your head right now. Like yes. It's kind of like fileless malware that still has files. It seems contradictory, Daniel. Yes, it does. But let me paint it in the right context, and maybe it'll make a little more sense, right? So you don't have to provision any servers, virtual, metal, or otherwise. The great thing about this, right? So this is a cloud service, something you will use in the cloud. And it basically takes the cloud services that you probably have already fiddled with from time to time and makes them work in conjunction with each other. They kind of orchestrate together so that at the end, you have the thing you're looking for. So let's say I want to spin up a web application, right? Well, normally in real life land, I would need a server, and then that would have to have an operating system, and then I would have to install a service like HTTPD of some ilk, so Nginx, Apache, IIS, whatever. And then I'd have to underlying technologies. So am I going to just run HTML? I'm going to get a little dynamic. I'm going to have some fun with some Python, maybe run a Flask app. How am I going to do all this stuff? And then I have to write those applications and then serve them up. You get the idea. There's a lot of work that goes behind that. And not only that, but even if it's a virtual server, I'm paying for the storage. I'm paying for the uptime on the server, and so on and so forth. With serverless, I just kind of say, okay, well, I can build files. That's fine. Let me just stick them in an S3 bucket. I'll go Amazon but this will work in Azure and stuff like that. I just have to shift over to whatever their technologies are for doing this. So, okay, well, I can stick my HTML files and my Python scripts and my Perl files and whatever weird thing is I'm going to make for my website, probably PHP. And then I'm going to slap them in an S3 bucket. And then I can use Lambda functions, right? So I just build a function in Lambda, and I can make things work that way. I never actually spin up any servers, but all these services, when I need that stuff, have access to RAM, memory, RAM and memory are the same thing. RAM, CPU, networking, and storage whenever they need it, and then just do the thing I've asked them to do. Cool thing about that for me is I can build my application, and I only get charged for what I'm using. I don't have a server just sitting there waiting for someone to access my application. When someone wants to access that application, it spins all that up in like super fast time and goes, here you go. And then I only get charged while that's happening. And then I can cut out. That's why we like serverless technology. So it's basically an orchestration of cloud services working together in conjunction to facilitate your application's infrastructure.
So does this come up when we hear people talk about like the different cloud models, like software as a service, platform as a service, that kind of thing, where like there's infrastructure involved, but you're just not hosting it? Like there's servers and stuff involved, but you're not the one hosting those servers? Or is this like a totally different thing?
So it's a different thing, because this applies across any of those as a structure.
Okay, gotcha.
Kind of things, right? Because you don't have to worry about, you can still be doing infrastructure as a service, but I can still use serverless technology.
Oh, okay.
Within that, right? So I would be charged for whatever infrastructure as a service that I've spun up, but I will get charged less for whatever serverless technologies that I'm using, because I'm not utilizing the servers that I've spun up. I'm just utilizing Amazon.
Right. Okay. Gotcha. I understand now. Thank you.
I know it's a
it's
little
good.
abstract, but
yes. Okay. I understand now. Thank you for clarifying. Yeah. So that's serverless. Then we also want to talk about the idea of virtualization, right?
Virtualization. Now, something we can all get behind, right? Mm-hmm. Hopefully you've heard of virtualization. If not, welcome to the 21st century, you caveman, you. Okay, cave person, right? As it were. And there's this wonderful thing that's happened. We have realized that when we make something, we don't typically use it to its most efficiently. There's always some leftover. There's always some. And when it came to computers, we saw that happening, right? I've got a computer sitting in front of me. You've got a computer sitting in front of you. You are watching one right now. You're not pushing it to 100% CPU usage, 100% RAM usage, 100% disk usage, 100% network usage, are you? If you are, I mean, I'm not saying I've never done it. It does happen, but it doesn't happen all the time. What do we do? It'd be nice. What if Sophia was like, well, I don't have as much money as you do to buy that nice new MacBook Pro or whatever. Let me borrow a couple CPU cycles and a little bit of RAM, some storage on your system, and I can spin up a computer virtually. This is virtualization, right? It's utilizing the unused resources in somebody else's computer. Well, on your computer with straight up virtualization, but if you move this into, because it is basically the foundation of cloud services, then it becomes somebody else's computer, right? So when I go to AWS and I go, I would like an EC2 instance, thank you. He goes, cool. Amazon has farms and farms of servers. And they go, here's a little bit for you. How much would you like? How many CPUs would you like? How much RAM would you like? How much storage would you like? How much bandwidth would you like? And I go, ooh, it's like a little a la carte.
I was going to say, it's like a buffet.
Yeah,
you just pick what you need.
So much fun, right?
Yeah.
And
Build-A-Bear.
it's wicked cheap because I'm not using all of it. Sophia can then come by and go, oh, that seems like a good idea. Let me do that too, right? So that's why without virtualization, we would not have cloud like we know it today.
Okay. And when we talk about virtualization, it looks like there's two types.
Yes,
so there's
there are.
Bare metal and then hosted, which bare metal virtualization sounds like a band to me. But, so what's the difference?
Yeah. Well, they got great tunes. So
it's true. Yeah.
Check out
by their albums.
Spotify or wherever you.
It's only on vinyl. Sorry.
Yeah. Oh, that's right. Yeah. We're going back, right? All things old or new again. No, so bare metal is a type 1 hypervisor, as it is more technically called. But basically what ends up happening is the software that runs the virtualization, also called a hypervisor, it sits on top of the actual RAM CPU. Like you install that onto the hard drive, and instead of installing something like, Linux or Windows Server, you just installed a hypervisor. So this is going to be your VMwares, your Citrix, these things of the world that they sit right on. They have direct access into the resources that it's going to kind of chop up and devour. Here's your little piece of it. There's your little piece of it. There's your little piece of it, and so on and so forth. So that's the type 1. That's why we call it bare metal, because it sits right on that server. It has direct access to that. There's no layer of abstraction to get to those things. The hypervisor is the first layer of abstraction to your virtualized hosts. Okay? Type 2, aka hosted, is probably what you and I are normally running. So I am actually running hypervisor. Let's jump into my computer here. And you can see I am running, this is VMware Workstation Pro. This is what runs all the infrastructure for any demonstrations I do. You can see I've got a bunch of servers over here for running X, Y, or Z things. All these different lovely, I've got Linux, I've got Windows Server, I'm running Kali, I've got different exploitable things. I can do that because of virtualization. Now, type 2 hypervisor, it is running on top of my actual OS. So there is an operating system installed, which is Linux Mint. The VMware Workstation is a software application that runs on top of that operating system. So there's that extra layer of abstraction before you get to the actual resources. You have to go, kind of got to know somebody, also known as your host operating system. Okay? So that's the difference. But here I can kind of do the exact same kind of things. A lot of times there is a bit more featureful stuff going on with the bare metal type 1 hypervisors, which is why it's appropriate for enterprise level virtualization or cloud virtualization. So like Amazon and whatnot are going to use those bare metal hypervisors, whereas you and I are most likely going to use the type 2 hypervisors hosted on our machines so that we can build environments, do testing, maybe build a sandbox, or do whatever we like. And that's the great thing about that. So I can build all sorts of great stuff. I can take snapshots, I can revert, I can make changes, not have to worry about destroying anything. It's a really nice technology. It's why we lean on it so heavily. So I love the virtualization. I remember when it first started, and I was like, this is This is game changing.
Mm.
You know, it was a different world, whereas before I had to buy 6 laptops to have a lab at my home, and now I just need one really good laptop so that I can make a bunch of small, okay laptops to run my environments.
No, sounds a lot more convenient than maybe it used to be.
Absolutely. You
Back
ever
in my
lugged around
day.
6 laptops?
No, I
They
can't
are
say that
not
I have.
light.
It's on my to-do list,
Yeah.
my bucket list. So we talked about serverless. We talked about virtualization, type 1 and type 2.
Yep.
Important distinction. And the last thing we want to cover today is containerization, which I know that I've talked about with you before, but maybe refresh my memory.
Oh yeah, we've had this conversation. Maybe we haven't had this conversation.
But we have.
We've had this conversation. Containerization, it's really nice. So now we take our idea of virtualization, right? And we go, man, virtualization's great. Love it. Nothing bad to say. I will put this out there, is that, you know, if I need a virtual environment, I'll have to get an ISO image to install an operating system, and then I got to provision, you know, all the RAM, CPU, storage, so on and so forth. Then I got to run through the installation process, get that built, and then from there do some configuration, and then maybe I got to install some technologies. Let's go back to our analogy of I want to build a web app, right? These are all the things that I would have to do. I would have to provision hardware. I would have to build the virtual environment. I would then have to inside configure the virtual environment to prepare it for being a web application server. So I've got to install those technologies. And then once all that's done and configured, I can then start building my web app. A lot of work, right? I mean, it has come a long way from having to like actually go to a physical server and do all that stuff. With virtualization, we have made that a bunch easier, but now we make it even more easier with containerization. Containers are great. They're small. They're everything you need. And you just say, run this. And you go, oh, you want a HTTP server? Cool. What else do you need? Well, that's all I need. Cool. It's ready. What do you mean it's ready? Yeah, you're good to go, player. You got that. Sweet. And it was just a couple of commands away from making that happen. So they're very small. So when it comes to resource consumption, they do a lot less than a virtualized environment would do, right? Because they're usually built upon very compact versions of like Linux or something, but it gives you access to the thing that you need. So really cool. Docker is probably one of the most famous, if not the most famous, like associated technology when it comes to containerization. Cloud technologies typically have their own version of containerization as well. You can use that if you want to go cloud. But let's take a look at the Docker Hub. And I say we continue this idea. Let's build an HTTP server so that we can make a web app if we wanted to.
All right.
How's
It's like Build-A-Bear, but with a server.
It is like
I'm excited.
with the server, right? This will be fun, right?
Will be fun.
So I'm in the Docker Hub. You can look through the Docker Hub. It's kind of cool, and you'll notice that just here's some very popular ones. So BusyBox, if I wanted to spin up an Ubuntu server, I could, or Python, Postgres, and there's Apache HTTPD right there. So I just need to do, let's jump over here. Got a terminal ready for. I would just do a sudo docker. Actually, you know what I'm gonna do? I'm gonna do sudo su. And get my password in there. Yeah, I'm just gonna drop to a root prompt because you need to sudo everything. Otherwise, I'm just gonna do this way. So I'll do docker pull HTTPD like that. You wait, it says cool, pulling from the library. Now the image that I already have is already up to date. It's at the latest. So excellent. That's step one, done. Cool. Next thing we do is we run it. We say, hey, I'm going to give it a name. I'm going to attach it to the network interface on a certain port. And I want to tell it where it's going to pull the files from. Simple. We like it, right? So we say docker, and then we tell it to run, do -dit. And basically this is just, make it interactive, and it's just got a couple of things going on there, but dit is a very common way to go. We'll take a look at that in a second. Then tell it -host name. What do I want to call this thing? I'm just going to call it my-http-app, like that. Then I'll do -p for the port. Where port do I want to go to? So I'm going to map this port. I'm going to say, well, my host machine's port is going to be 8080, but I want to map that to the container's port 80 because it's a web server, right? And I might be running something, you know, I don't want to compete and get an error. So I'm just going to go 8080:80, like that. Now do -v. This is where we tell it, hey, this is where these files are going to be from. So I can give it, you know, whatever I like. So this is /home/ Well, I'm logged in as Kali, so I'll just do it Kali. That seems fine. Then do colon, and then where do I want to map that to in the container environment? Well, it's a web server, so /var/www/html is going to be the soup du jour of that. Then I tell it what container I want to run, which is HTTPD. Sometimes you'll see like colon, and you'll have to give it a version number. You might get an error if you don't. So you might need to know the version number. I'm just going to go ahead and throw that on the fire just to make it easy for us. Now we fire away, download a newer image, and look at that. It did grab a newer image because for 2.4, one must have come out. It looks like there was no error other than unable to find that image, which it fixed itself. Excellent. So now when I go back to here, I open a thing and I go to 127.0.0.1:8080, like so. I don't know if you can see that there, right? Just going for that good old local host. I hit visit. Look at that. It works.
It couldn't be more straightforward.
Yeah, that's the default Apache
It's kind of nice, though.
index.html.
That would reassure me as a like,
I mean,
God.
It is very nice to say, oh, okay, well, everything is working as I have
as
planned.
intended. Yes.
And if you need to like do some administration stuff, you can do things like I'll clear here. I'll do like a Docker. I can't spell PS, and that'll show me what's running here, right? And this is a little. We'll just scroll in. I can see what's happening. I've got a lot of Docker containers running, if you can't tell, right? There's quite a few of them here. But there's our HTTP right there. I can see the command that's running, how long ago it was created, how long it's been up, all the ports that's been mapped, and the name of the application itself. Cool. You know, so I've got a bunch of other stuff too. This is all for you doing hacking demonstrations. It's a lot of fun. But then I'm like, okay, I'm done with this. I'm ready to kill that thing. I'm just going to do Docker stop, and then I'm going to give it the name that my HTTP app that we have over there. So, whoa, yeah, I'm going to do this
Make
again.
it human readable.
Yeah, Docker stop my-http-app. And if everything goes according to plan, there we go. We revisit the websites. I redo the page, unable to connect, right? Because I've stopped that service from running. Tell me how hard this has been, right? This is a pretty straightforward process. And then when I'm done with it, I'm like, hey, you know what? It was fun to test. It was fun to play. You probably do want to do this is like delete any because you can fill up your hard drive pretty quickly. If you're like Docker pull, Docker pull, Docker pull. Yeah. And you're like, where's all my hard drive gone? Well, you got a little crazy with the Docker pull there, buddy. So make sure you remove them. So Docker RM, and then give it the name that you gave it. So this is going to be my-http-app. And then if I do a Docker PS, that should no longer show up in this list. And it does look like it is gone. So there you go. That's containerization. That's why we like it. It's quick. It's fast. It's light. It runs like a gazelle, right? And it just makes our life easier. I can't tell you how many things, like if you've ever gone through a rough installation where it's like, oh, you don't have the libraries, you don't have the dependencies, you don't have this, you don't have that, you're on the wrong version, you're blah, 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 right? This runs anywhere, right? The environment is always the same because it's the containerized environment. So it doesn't matter if I move this to Linux Mint, doesn't matter if I move to Windows, doesn't matter where I move it, on what platform it's on. That's the beauty of containerization is you always have what you need because it's all in the container. And the container runs it. You don't have to worry about it. You just use the thing you need. It's great.
This episode brought to you by the Ad Society for Containerization. Yes. I'm just kidding. This isn't
sponsored by Docker.
This is not sponsored. Docker pull, Docker pull.
Yeah.
So I think that's going to do it for this episode on common infrastructure concepts. Lots of good information. Hope you're paying attention. Thanks so much for walking us through this, Daniel. And thank you for joining us for this episode. We'll see you next time.